Hi everyone and welcome to this video. So I've already recorded a video on parts A, B, and C. So this video will teach you how to calculate the slope of a line given the ordered pairs of 2 points on the line. So let's get started. So without a graph, we are going to have 2 ordered pairs, and we're just going to label them x1, y1 and x2, y2. Note that it doesn't matter which one we call point 1 and which one we call point 2. Then what we're going to have to do is we're going to have to use the slope formula that I mentioned in the very first of these videos, and we are going to plug in those values, those 2 points, and then simplify if possible. So let's do an example here. So we are given 2 points, 2, 5, and 6, 3. Again, I invite you to remember that it doesn't matter which one we call point 1 and point 2, but it does matter that we call the first number x and the second number y. So I always go through and do that first. And then usually out of sheer laziness, I'll call the first point 1 and the second point 2. Again, it really does not matter. So, as you can see here, the slope formula has been written out for us. M is equal to y2 minus y1 over the quantity x2 minus x1. Now, most instructors will not give you this on a quiz or a test, so you might want to think about memorizing it before you get to that point. So let's just start plugging things in. So remember, we have y2 minus y1 over x2 minus x1. Well, what's y2? y2 is 3. So we plug in 3 for y2. What's y1? Well, y1 is 5. So we plug in 5 for y1. x2 is 6, and x1 is 2. So 3 minus 5 is negative 2, and 6 minus 2 is 4. So are we done at this point? Have we finished? No, because we always have to reduce. Negative 2 over 4 reduces to negative 1/2. So my final answer is that we have a slope of negative 1/2. So what you can do as you do these problems is you can graph these 2 ordered pairs and show yourself, prove that the slope is negative 1/2. So let's plot the point 2, 5. That's right here. And then let's plot the point 6, 3. That's right here. And then let's connect them with a line, and let's prove to ourselves that the slope for this line really is negative 1/2. So I'll call this point A and this point B. So here, my delta y is negative 2, and then my delta x, hopefully you can see here, is positive 4. So the change in y over the change in x is negative 2 over 4, or negative 1/2. So I wanted to do this both ways so that you could understand that the slope formula is the algebraic equivalent to what we were just doing in our previous videos graphically. So technically, you could use the slope formula, or you could always plot 2 points and graphically find the slope. Let's do another example. So here we have the point 4, negative 2, and the point 5, negative 1. Okay, and again, just for the sake of sheer convenience, I'll call this one point 1, and I'll call this point 2. So remember, the slope of our line is y2 minus y1 over x2 minus x1. So let's start plugging in some values. So y2 is negative 1, y1 is negative 2. Be very careful about your signs, or else you might end up making a mistake. x2 is 5, and x1 is 4. So what's going to happen to our minus and negative? Hopefully you said that they're going to become positive. So negative 1 plus 2 is positive 1, 5 minus 4 is also 1. So the slope of this line is just 1. Again, we can graph these 2 points and connect them and prove to ourselves that this really is the proper slope. So the 0.4, negative 2 is right here, and the 0.5, negative 1 is right there. Again, we can create this nice little line here, and then we can find, we'll call this A, call this B. So the delta y here will be positive 1, and the delta x here would also be positive 1. So graphically, we can still see that our slope is 1 over 1, or just 1. So again, the graphical analysis verifies what we did algebraically. Let's do another problem. So again, we're given 2 points. So we'll label them xy, xy, and then we'll call this point 1, and we'll call this point 2. So remember, our equation is y2 minus y1 over x2 minus x1, and then we can start just plugging values in. So y2 is 0, so then we have 0 minus y1, which is negative 3. Again, be careful with your signs. Then we have x2 is negative 2 minus x1, which is negative 6. So this is where things can kind of start getting weird or tricky if you're not very careful about your signs. So the minus and negative turns into plus or positive in both the numerator and the denominator. So the numerator becomes plus 3, and the denominator becomes positive 4. So our final slope is 3 over 4. Let's graph these two ordered pairs just to verify graphically what we just did algebraically. So there are our two ordered pairs. I'm going to connect them with a line, which doesn't always work. Okay, so let's see. If I want to find my delta y, you can see our delta y is positive 3. Call this again point A and point B. And then our delta x is positive 4. So when we put those together, delta y over delta x, does that give us the same answer that we got algebraically? And the answer is yes. Yes, it does. Okay, let's do this next example. So again, I just go through and label my ordered pairs x and y. And then I usually call the first one 1 and the second one 2. So remember, this is our equation here. Usually if you just sort of write it enough times, it ends up sort of lodging itself in your brain without much effort or energy at all. So that's what I used to do if I had to memorize a formula. I just write it a bunch of times. So y2 is 10, y1 is 4, x2 is 5, x1 is also 5. So 10 minus 4 is 6, 5 minus 5 is 0, and then the $1,000,000 question is, what is 6 divided by 0? And your calculator will tell you, well, your calculator will say error, which you have to translate to the word undefined. So let's plot these 2 points and just really verify for ourselves that, in fact, we are graphing a vertical line. So we have the point 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And then we have the point 5, 10. Now, unfortunately, this numbers would be off the charts. It would be up here somewhere. But hopefully you can see that it does, in fact, agree with being a vertical line. So since they do have the same x value, you would get a vertical line, even though, again, 10 is slightly off the grid. All right, let's do this problem. So again, we have x, y, x, y. And remember, as you watch these videos, it's always a good idea, as soon as you start feeling a little bit comfortable with some of these problems, to pause the video, see if you can work the next example on your own, and then unpause the video and just kind of click through and make sure you are correct in your answer. Okay, so y2 is negative 1, y1 is also negative 1, x2 is 2, and x1 is negative 2. So be really careful here. Again, watch your signs. Minus and negative becomes plus and positive in both the numerator and the denominator. So we get 0 over 4, which is 0. And that's our final answer. And then we'll just plot these 2 points, -2, -1, and 2, -1. And hopefully you can see that if I were to connect those 2 points, I do in fact obtain a horizontal line, which we just learned that horizontal lines have a slope of 0. And that's it.